Section 2C. Now it says 2B in here, 2C. This one should be C, as I mentioned. Interpreting graphs. Now there's no graphs on here. You should have been handed out a graph that's actually written on here. If I do it by hand, it looks like this. So that is what we're looking at. Now we're supposed to answer 3 questions. The first one is, what are the max and minimum values? Well, notice the arrows go up forever. When we talk about max and minimum, we're talking about y values. So as it goes up forever, there is no max. So we would say none. But there is a minimum. The lowest value that it seems to get for a y value would be right here. So we would say -3 is considered the minimum. The next question is, what are the zeros? Well, zeros are one way of asking for x-intercepts. So what are the x-intercepts? In other words, where does our graph cross the x-axis? It crosses it at 2 points. So we would say the zeros, or x-intercepts, are -3 and +3. The last question is intervals of increasing and decreasing. Now here's where a table might be best suited. If I have a table and I plug in an x and a y, or I plug in an x, if I do what I have always done, I see that if I plug in a -3, I get 0. If I plug in a -2, I get -1. This is using the function or just looking at the graph. If I plug in a -1, I get -2. A 0 is -3. That's a 2. If you plug a 1 in, you get -2. Plug in a 2, you get -1. And if you plug in a 3, you get 0. Now if you look at those values, as you go this way, in other words, if you're thinking about a number line, as you're going left from small values of x to bigger values of x, or this way, same idea, the y values seem to be getting smaller until here. So we would say that it is decreasing from -infinity, because I could have started at -10 or -100, but the idea is that as I go and plug in bigger x values, the y gets smaller, so it's decreasing. But it's decreasing until a point. Now what x value does it stop decreasing at? It stops decreasing when x is equal to 0. That's when it hits its lowest point. And then it begins to increase again. So it begins to increase from 0 to +infinity, because I'm starting to get bigger and bigger numbers. If I plugged a 4 in, we'd get 1. Plug a 5 in, you get 2, and so on. And that's how you would use that. Our next one here looks a little bit different. This one has a asymptote, which is a value that you are not allowed to plug into. Notice if you plugged a +2 in here, you get 0, and you can't divide by 0, undefined. So you get this dotted line that means that value can never be plugged into the function. You also have a dotted line that's at 2. That has nothing to do with being undefined. It just means that it's a border, a barrier of some sort. And if we graph it, you'll see what happens. What ends up being the case is, if you plug in numbers, and I'm not going to ask you to plug in numbers because you're supposed to see these graphs, so I'm going to sketch it out. It looks basically like this. And down here it looks like this. That's the function we're looking at. So if you look at that, and you ask yourself the key questions, is there a max or a min? It goes up forever on the top one right here, so there is no max. Is there a min? Well, again, this arrow goes on forever, so it gets smaller and smaller, so no minimum. Then you ask yourself, are there zeros? Well, 0 is an x-intercept. Are there any x-intercepts? And there is one right there. So you would say our x-intercept is when x is 0. And the last is decreasing, increasing, and decreasing. Now again, as you go left to right, or on an xy table, go from smaller numbers to bigger numbers. This one, the arrow points left, but that's if you're going left. We're talking about going right. So as we go this way, the y values get smaller and smaller, so it's decreasing. And even over here, as we go to the right, the y values get smaller and smaller. So the decreasing, I would describe as negative infinity to positive infinity. However, we can't plug in the value of 2, so we would say x cannot equal 2.